Hello, good morning everyone, or afternoon if you're on the East Coast. My name is Andy Dio. I'm your host, and welcome to our customer enablement session. Today we have Mimi Lan, application engineer at Saratech, and Mimi will be sharing some information and tips and tricks about NX CAD. But before I pass the presentation over to Mimi, I just want to spend a couple minutes talking about our customer enablement series. Um, Hey Mimi, can you move on to the next slide? Perfect, thank you. So this is a web-based training series that we offer free of charge every first and third Thursday of every month. And our focus is really on Siemens PLM software. So we have different topics ranging from NX to FEMAP to Solid Edge. And we have application engineers, subject matter experts, and if some of you in the audience, if you have something that you would like to share with the team or with everyone else, just ping me and we can put you on as a presenter as well. So our goal for this series is really to help everyone of our customers who uses Siemens PLM product get the most out of your software. We want to share knowledge and make sure everyone build a strong community of users so that we can all benefit and help each other out. So it's, again, if you have any questions at all during this session, just go ahead and type it into your chat box, and I will let Mimi know that there are questions that's coming in, and then we'll address it right then and there. So we want this to be interactive, so please feel free to type in your questions. So with that, I'm going to transfer the presentation over to Mimi. Mimi, over to you.
Thanks, Andy. So like Andy said earlier, my name is Mimi Lan. I am an application engineer with Saratech. And today I'm going to be going over some NX tips and tricks. Here are some of the topics, or here are the topics I plan to cover. Hopefully I can get through all of them. And if not, we'll probably push one to another tips and tricks session. But changing measurement units on the fly, controlling thread definition in expressions, using arrangements to define different assembly positions, and then a convergent modeling demonstration where we'll design a cranial plate. And I will be going through what exactly this means as I go through the demonstration. So with that, let me switch over to NX, and we'll go over the first topic, which is changing measurement units. So what you see here is a model that I have created using an inch model template. So for example, I'm going to go up to my analysis tab and click on simple length just to pick up a measurement from somewhere. And you can see that the measurement is being taken in inches. This is a 1-inch edge length. But let's say that, I don't know, that I'm more comfortable with metric units, or that I need to see the measurement units that I take in millimeters. So an easy way to do that when you have an inch model is to go to this menu button here, go down to the analysis, and then go down to units, and you can change to whatever unit you want to see the data displayed in. In this case, I want grams and millimeters. So I'm going to go back, go to simple length, click on this edge, and now it says 25.4, which is equivalent to 1 inch. So not only can I see lengths in that, if I go to my measure body tool and I click on this body, this information window pops up, and I can see that I get volume, area, mass, etc., weight, all in metric units that I had designated. And then to change it back, it's simple. Just go back to menu analysis, units, and I'm going to go back to pounds and inches because that's actually what I'm more comfortable with. So that one was a quick one. Second topic, let me switch back to the PowerPoint real quick so you guys can see what topic number 2 is. Controlling thread definition in expressions. And this is kind of a oddly specific topic, but I think that it is important for, it can be important, and when it is, it really helps to know how to do this. So in my own experience, I have been building like a family of parts, like of hardware for my reusable parts library. So I have a range of nuts that go with screws and bolts. So these nuts have are created through a part family table and driven through expression. And so being able to drive that geometry is quite important to me. So what we have here are 3 holes, or 3 symbolic threads created, 2 through the thread feature and 1 through the hole feature. Only the symbolic threads created through the hole feature can be controlled through expressions easily. So I have a workaround for if you have, let's say, instead of a nut, you have an external thread like a bolt that you wanted to control through expressions. I have a workaround that I'll get to at the end. So that's why I have this shaft here. So to start off, I am going to highlight the threaded hole feature in my part navigator. If I go to the details tab, this is kind of like a shortcut to the expressions relevant to that feature. So this is going to be equivalent to going to like Control E and looking at your expressions table. So let's start off by changing this thread to another coarse thread. So let's say that instead of a 1/4-20 thread, I want a 3/8-16 thread. So I've typed in quotation marks and then typed in the correct syntax and the end quotations because this expression takes a string to control this. So, and I hit enter, and then you can see that the hole has changed diameter. So it has the correct capped hole size and the correct major diameter, which is what this little dotted line represents in the symbolic thread. And this is all just driven by NX's internal tables for what major, minor cap diameter should be for their various thread sizes. If I wanted to change to a different thread standard, I'm going to have to also change, make sure I have the appropriate thread standard set here. So just as like a demonstration, let's say that I wanted a 1/4-28, which is a fine thread. So I'm going to show you that when I type in 1/4-28 and I hit enter, that the hole has not changed. And if I'm confused as to why that didn't generate, you can see there's a little warning arrow in the part navigator for the threaded hole. And it's basically trying to tell me that your inputs don't make sense. It needs to have the correct thread standard with an available thread size in that standard. So no big deal. I'm just going to go to this expression for thread standard and type in inch UNF, and it's all fixed. So syntax is very important in driving these threads correctly. So if I sort for, let's see, user-defined expressions, to make it easier on myself, like if I couldn't remember exactly the syntax, like it's capital I, N, C, H, space, capital U, capital N, capital C, end quotations, If that's just too much for me to remember, you can create variables that are more, I don't know, something that you can kind of recall easily. And then let's say I want to now change this threaded hole. So now I have filtered for the threaded hole features. I can use expressions to control it instead of actually typing in the syntax. So let's say I want to go to course thread again. So I know I started everything with thread. You can see it gives me a bunch of options. I'm going to go back to UNC, hit enter, and then the value propagates properly on the side. And I'm also going to change this one to another thread. And I just said the second UNC thread that I have in here, 3/16, hit OK. And then I got the 3/16 UNC threaded hole again. And I was saying earlier that there's a workaround for doing bolts. I think that this is just something that Siemens is working on, trying to improve the expressions, capability of expressions to control threads. I think that this hasn't quite caught up, but let me go through this. So typically, so this one's created through the thread feature. You can see the dialog box here. And the way you pick what thread you want is to go to this table and to pick, the right thread. And if you look at the Details tab, you can see that you can't change a lot of these parameters through expressions. You see this like, I don't know, like no sign next to the pitch, angle, minor diameter, major diameter. You can only change the length of thread or the shaft size, and that doesn't give you what you want. So one workaround for this is to change everything to a manual input. And this is a little tedious, but take a look. When I go back to the Details panel, now I can change everything. I can change major diameter, minor diameter, pitch, etc. But that also means I have to put into a table what the major diameter, what the minor diameter, and what the pitch is for every thread size. So that machinist handbook becomes quite important at that point. So it's not the ideal way, but there is a way to control external threads through expression, so it's not quite that nice yet. All right, well that summarizes that topic. So arrangement. So hopefully you guys are familiar with arrangements, but and if not, then I think you guys are in for a treat because this is a very useful tool. I am going to go to my completed model assembly with arrangements, and let me just briefly show you what arrangements do. So here I have an excavator arm, and as you can kind of imagine, it has like a range of positions it can be in. So I'm going to go to the assembly navigator, to the top level assembly, come down to arrangements, and I have defined closed, extended, or mid-range. Right now the model is showing an extended position. So if I want to show the closed position, I click that, and now you see the excavator arm in its closed position. And similarly, let's go to the mid-range, and then for the extended. So if you work with a lot of moving mechanisms, arrangements will be your friend. All right, so this is what I started with. For brevity, I will probably just show you closed and maybe extended, but we'll get this model set up for having arrangements. So first thing I'm going to do, just for clarity, I'm going to unpack these hydraulic cylinder assemblies just so I have better visibility. And I am going to need to have these hydraulic cylinders properly assembled to their relative pin positions. So the way to do that, I'm going to go to the Assemblies tab, Assembly Constraints, Touch, and in first center axis, and to zoom in on one of the pins, click the center line, go to the other pin location, click the center line, and it hasn't moved yet, but that's all right. I'll get to that point in just a second. I'm going to do the same thing here and there. So now I have the center lines properly defined. And like I said earlier, these hydraulic cylinder assemblies haven't moved, and that is because at the sub-assembly level, if I opened each of these, they have their own sets of constraints that is conflicting with that constraint I just added for them to be collinear with that pin location. So what you do is right-click and hit Override Position, and that basically tells NX that for this level of assembly, ignore the constraints below, or override conflicting constraints below. And that is what we want to do. So now they are both correctly pinned in place. The next assembly constraint that I need to be able to drive the various positions of this arm are distance constraints. So, you know, if you consider this to be a 4-bar mechanism of sorts, you need to define the lengths of some of these, I guess, of the hydraulic cylinders. So I am going to hide these just so I have an easier time clicking what I want. And I'm going to define distances. I'm going to define it from that point to this point. I'm just going to accept the default, or actually hit apply. And then from this point to that point. Okay. Now I also have those distances available to me, and unhide these. So now that I have all the constraints that I need in place for arrangements, I can now start creating my arrangements. So first step, I am going to go to the top level assembly. I'm going to go to the Assembly Navigator and right-click on the top level, go to Arrangements, and hit Edit. So I can start telling NX that there are going to be arrangements in this assembly. I want to rename this first one just because I want to. And I am going to call this one the closed arrangement. I'm going to make a copy just so I have another one, and I'm going to call this one the extended arrangement. And hit close. So now if you go here, you'll see there's a closed and there's an extended. But I have not defined what is closed and what is extended. So second step, go to your constraint navigator. And for this demonstration, I only need the distance constraints that I had placed to be arrangement specific. It doesn't matter which arrangement it is, the collinear constraint that I had done first, that is the same for all arrangements. So, see. So I did that kind of quick. I had right-clicked and hit Arrangement Specific. And you can see that has changed the icon here. And that just basically tells you that now it's an arrangement-specific constraint. So, let's see, the next thing you do is to start defining what these arrangement-specific constraints need to be. So I'm going to right-click on the first distance constraint that I made, click Edit in Arrangements, and define a value. So right now I'm in the closed arrangement. You can see it's highlighted here. And just because I've already gone ahead and done this earlier, I know this is supposed to be 3025 millimeters. And I'm going to hit OK. And then for the second distance, I know this one's supposed to be 3010. And then now I have a closed excavator arm. I'm going to go back to the assembly navigator, click on the top level assembly, and switch over to the extended and define that. So after choosing the extended arrangement, I'm going to go back to the constraints navigator, go back down to the distance, and make them both arrangement specific again. Right click on one, edit an arrangement, and define the extended distance for this one. And I know this one's 1875, just because I know. And do the same thing for the second distance, which is 1860. Oops. There we go. And now I can sit back and right click, and I'll go between the two arrangements as I please. So that one's a fun one. That brings us to our final topic. Go back to the PowerPoint slide so we can see what that final topic is. And I will go over Convergent Modeling, which is really cool. It's a new feature in NX11, and one that I'm actually particularly excited about because I don't know, it's just really cool. I have a history in medical devices, so I know the pains of trying to work with facet geometry from like MRIs or CT scans, and it is not easy to work with those formats in a parametric setting. But so Convergent Modeling allows you to do that. And so you see this cranial plate that that's created here. That was done in like 5 minutes, maybe 3 minutes. And that leverages the geometry of this underlying STL or facet body. And that is pretty neat. So let me just talk less and show more. I'm going to start with a blank model. And the first thing you do is import your geometry. So I'm going to go to File, Import STL, because I have a skull STL to use. And I am going to set the output type to Convergent, because that will allow me to use it like a parametric model. And the units are millimeters. So now I have a geometry to work with. And I'm going to just really quickly change the visibility, transparency of this model, because that just makes it a little easier for me to work. And the first thing I want to do here is to create the general outline of this plate. So I'm going to make a sketching plane. I'm going to pick a spline tool and create a nice organic round blob shape for my plate. And maybe I want it to be a little more, I don't know, a little bigger. Hit Finish Sketch. And now you can see I have this sketch plane on the center coordinate system. The next step is to use Divide Face to project that spline onto the skull surface. So I'm going to hit Divide Face, select the skull, and then select the spline. And now you can see I have a geometry here to work with. I am going to extrude that face that we just created. So extrude, click on this surface, convergent face, and I don't want it to go that way. And I want this to be a 2 millimeter plate going out from the skull, not into the skull. And I'm going to make sure my Boolean is set to none because it is not part of the skull and it is not cutting into the skull, but just sitting on it. And now I have some, I don't know, blob-shaped plate that's formed to the shape of the skull. And let's say that I want this plate to be like a millimeter to, I don't know, wider. I think 2 is good enough. Just because I need it to somewhat overlap or not, I don't know, cover more surface area. So I can offset face to enlarge that plate slightly. And perhaps, you know, part of my design requirements, I need this plate to have holes, you know, so the skull can breathe or something like that. Go to my part navigator. I'm going to unhide my original sketch that was auto-hidden when I created the divide face. And I am going to sketch on the same plane. Oops. Turn this around again. Create a circle, and let's make it a, I don't know, 2 millimeter diameter circle, anywhere in the center. Hit OK. And I'm going to leverage pattern geometry. I'm going to click this circle to pattern, and I'm going to use the boundary curve. So you can define boundaries for patterns. Let's see. Click on this curve, and then it kind of fills that boundary with patterns of the circle. And I think square, maybe a diamond. Diamond looks pretty good. And I want it to be not so close to the edge of the boundary. Hit OK. And now I have a whole bunch of circles I can now extrude. So I'm going to highlight the sketch and the pattern, hit extrude, go to subtract, and see here, drag this out. Why are you not? Oh, sorry. There you go. I'm going to cut through that body. Hit OK. And now you can see I have a porous plate. So let's hide all the unnecessary geometry. Let's make this one also hide. Let's bring the display of this object back to full opaqueness. And let's edit that object display to some nice color. Let's pick a blue. It's easy to see. And that's it. You can create a plate in like 5 minutes. So that's a really cool tool, Convergent. So if you're working with a lot of STLs or scan data or more abstract geometry, this is a really nice tool to bridge that interface between like facet geometry and parametric modeling. So I don't think we got any questions. I'm not sure. That was my last topic. So I guess I'll hand it over to Andy.
Great, thanks, Mimi. Yeah, if there's any questions at all, feel free to type it in, and Mimi can answer them right here. Or if you're shy and you don't want to ask question here, after you log off this session, there's a short survey that pops up. I think there's only 4 questions or 5 questions on there. Please take a minute or so just to give us some feedback, and you can ask your questions there as well. Also, I want to remind everyone, don't forget to subscribe to our blog, YouTube channel, and there's also, if you need support on NX or any other Siemens product at all, you can go to support.saratechinc.com and submit a case, and we'll be more than happy to help you out. But this recording will be uploaded to our YouTube channel probably later on today. And we have tons of videos on our YouTube channel as well on this and other topics. So go ahead and subscribe, and we'll notify you whenever there's a new video that pops up. With that, I think we hit our 30-minute time allotment. I don't want to take any more of anyone's time. So thank you for being on with us today. And thank you, Mimi, for a very nice session. And hopefully we'll be able to see all of you on a future training session.
Sounds good.
Thanks, everyone. Have a great day.